At this point, we're moving into new territory on integration. Integration by parts is not a method that was taught last year. It's something that's entirely new for the Calc BC course and for IB Math HL. So, just for your information on integration by parts, some integral expressions basically are the results of the product rule. So remember that integration is basically undoing a derivative. So when the product rule was used to take a derivative, integration by parts is sort of the method that's used to sort of undo that product rule. I want to show you where integration by parts comes from. So let's just sort of quickly take a look at that. Suppose that someone had taken the derivative of a product rule. So let's say there was some function u times some other function v. Alright, so there was a u function, there was a v function, somebody took the derivative of the product. If they did that, they would get, let's see here, the derivative of the first thing times the second thing. So that would give me v times du plus, and then we would have u times dv, right? So we've got this setup here, right? Now the idea is, if this statement is true, and I guess I want you to stop and think about it, like this statement here should be permanently always true, right? If you ever have the derivative of two things, you will use the product rule to do it. In fact, all I'm really saying here is, hey, this is the product rule, right? So there it is. Now if I want to, I could go through and take the integral of this thing, right? The integral of all three of the pieces. If I did that, I would get, like on this first term, I have the integral of the derivative, so that's just going to leave me with u times v. So I will have that u times v is equal to the integral of v du plus the integral of u dv. And all I'm going to do here is I'm going to take this thing and subtract it to the other side. Right, so in the end, my final expression is the integral of u dv is equal to u v minus the integral of v du. This right here is the rule for integration by parts. Right? And what it says, and I know this is really confusing and it doesn't look at all helpful, it basically gives you a way of transforming an integral. It says, look, if your integral is made up of two pieces, a piece that you're going to call u and a piece that you're going to call dv, then you can rewrite that integral like this. You could do u times v minus the integral of v times du instead. This is really something you need to memorize. The integral of u dv equals uv minus the integral of v du. Memorize it, get it in your heads. We're going to spend today and tomorrow working with integration by parts and related methods. So get that thing memorized. Alright, so I know that this doesn't make much sense yet. The next thing we talk about is so when and how do we use integration by parts? Let's first tackle when. The most common case for the use of integration by parts is when your integrand, the thing you're integrating, is made up of, again, two pieces. It's going to be the product of a power of x and some other integrable function, right? So you can sort of like take a minute to process that, right? We are probably going to use integration by parts when you have something that is the integral of a power of x times some other function, right? If we have a power of x and some other integrable function. I mean, I just wrote down two of those, and if you think about it, these two are integrals that we would never have been able to do before, right? So that's sort of how we're going to do it, right? That's when we're going to do this. Now, how are we going to do it? Let me sort of write out some steps, and we'll talk about those. Actually, in the interest of time, I'm just going to go on to my first example. We'll do that example, and then we'll write out the steps after that. So here it is, the integral of x times the sine of 2x dx. First note, I cannot do this problem currently. Like, without integration by parts, we have no hope, right? Like, u substitution is like our one trick. If you made your u 2x, there's not anything I can do to cancel out this x here. I'm going to be stuck with it. There's nothing I can do. So here's integration by parts. Right? For integration by parts, remember that the rule is, and I really, until you've got it memorized, I would recommend writing the rule down every time. The rule says the integral of u dv is equal to uv minus the integral of v du. So this left side represents what we have. This right side represents what it's going to change into. And so our first step is to sort of recognize what we have. So what we do is we sort of write down, okay, if my integral here really is u dv, then what is my u and what is my dv? And you may have noticed here I wrote those on, like, if this was lined paper, these are two different lines. U is like on the first line, dv is on the next line down. U is most commonly going to be the power of x. So for my problem here, u is x. Okay? dv is the other integrable function, right? So the other integrable function here is the sine of 2x dx. Okay? Once you have chosen your u and your dv, and note, like, here's my u, here's my dv, notice that the entire integrand is made up of those two things, right? So now what you do is you take the derivative of the u and you take the integral of the dv, right? Because in order to work this out, in order to sort of change it into this, I need to know what du is, so I need to have taken the derivative, and I need to know what v is. I need to have taken the integral of this. So first, what is du? Well, du is like 1 dx. And what's v? Well, v is the integral of this. The integral of the sine of 2x dx is negative 1/2 cosine 2x. Okay? So now I have all the pieces I need, and I can finally do this transformation. I can change my integral into this one. Right? So because my original integral was u times dv, I can change it to this. So what is uv? uv is, uv. It's negative 1/2 x cosine 2x minus the integral of v du. So what is v du? v du is v du. Okay, the du is actually pretty simple. It's negative 1/2 cosine of 2x, and then the dx gets supplied by the du. And right here, like, I hope this is exciting, the new integral is totally doable. That x is gone. Because I was able to change out the u for the v, I got rid of my x and have this thing instead, which doesn't have the x in it anymore. So this integral is something we can definitely do. These negative symbols take care of one another. All I have to do now is do this antiderivative. I've got negative 1/2 x cosine 2x. The integral of 1/2 cosine 2x is going to be 1/4 sine 2x plus c. So there it is. I mean, that's integration by parts. Like, that's how it works. It definitely gets quicker as you get the hang of it. So don't give up right away. I don't want to linger on this slide too much. This video is already going to be long enough as it is. I just wanted to write out what the steps are for integration by parts in case you really wanted to write them down. We just ran through them in the previous problem. We're about to do them again in the problem that's coming up. The idea is just you choose a u and you choose a dv. Usually your u is a power of x. dv has to be everything else. Step 3 seems like a silly step, but the idea is you have to confirm that your original integrand really is the product of u and dv. So, like, make sure that, whatever you chose for u and whatever you chose for dv, that really is the entire product integrand. Step 4, find du by taking the derivative of u. Step 5, find v by taking the antiderivative of dv. And then once you have those things, once you have u dv and then du and v, you can transform the integral using the integration by parts rule. Remember that the rule was the integral of u dv is equal to uv minus the integral of v du. And then step 7 is simply simplify this new integral. Now, occasionally, that new integral also requires integration by parts. We're going to look at one of those problems next, so brace yourselves. Here it comes. Alright, so here it is. We want to evaluate this, this integral. If you're feeling up to it, go ahead and do the first integration by parts. Choose your u, choose your dv, and transform the integral. So if you're up to it, pause the video, do that, and then we'll check together. So I'm going to choose my u to be x squared, because that's the power of x. I'm going to choose my dv to be e to the negative x dx. The step after that is for me to find my du, which is 2x dx, and find my v, which is negative e to the negative x dx. And then I'm supposed to transform this integral by using the fact that it's supposed to be uv minus the integral of v du. Right? So uv is just the product of the u and v terms up above. That's negative x squared e to the negative x. Now minus the integral of v du. So now I'm combining my v and my du terms. That's negative 2x e to the negative x dx. Now my thought here is that I like to sort of simplify this a little bit more, so I'm first going to deal with the negatives, and then second I'll take the 2 and pull it out of this thing. We might as well just make our lives a little bit easier, right? So negative x squared e to the negative x plus 2 times the integral of x e to the negative x dx. If you left the 2 in, by the way, that's fine. It's not going to be a problem. So now what we do is we have to deal with the integral that remains. Right? Notice that that integral is still the product of a power of x with e to the negative x, but the power's dropped by 1. Used to be x squared, now it's just plain x. So hopefully with just one more integration by parts we'll be done. Right? So once again, choose your u, choose your dv, walk through the steps. My u is going to be x. My dv is going to be e to the negative x dx. That makes my du 1 dx. It makes my v negative e to the negative x. So once again, I'm going to use my rule, right? I'm going to use my uv minus the integral of v du rule to replace that piece. Right? So we got to be a little bit careful here. We still have all of the stuff that wasn't in the integral. So negative x squared e to the negative x plus 2 times this new integration by parts. So uv is negative x e to the negative x minus the integral of v du, that's just e to the negative x dx. And I just realized I was missing a negative here, because this integral I'm doing is supposed to be v du. There's a negative there. So now you sort of have to play carefully with the negatives, right? This negative cancels with this negative, and then this 2 gets distributed in. So this is negative x squared e to the negative x minus 2x e to the negative x minus e to the negative x plus c. Actually, we don't need plus c, because this whole problem was supposed to be evaluated from 0 to 1. Right? This was a definite integral, so now I need to plug in those 0 and 1 values. Just when we thought we were almost done, right? So we plug in 1 first. Plugging in 1 gets me negative e to the negative 1. 1 again is minus 2e to the negative 1. 1 again. Oh, you know what? I just realized I didn't distribute the 2 here. There we go. So this is minus 2e to the negative 1. Minus. Then now I'll plug in 0. Gets me 0 minus 0 minus 2, because e to the 0 power will be 1. So now just about done. This is minus 5 e to the negative 1 plus 2. And so our answer here basically ends up being 2 minus 5 over e, or I suppose we could get a common denominator and say it's 2e minus 5 all over e. Either one of these two answers is great, right? So this is an example of sort of a double integration by parts. Sometimes that happens. That it is what it is. I'll see you in the next video. No, that's not fair. I can't just say, like, I'll see you in the next video. There is a shortcut for when there are multiple integration by parts. We're doing that next. So take a break, breathe a little bit, and then come back for that one.